Hey guys, I hope you guys are doing good today. Today I would like to talk about database. So database is one of the critical component in your stack. If database is down, it is very hard to complete your entire transaction. Your application logic may definitely fail. So this is one of the important core component in your stack. So since it is core, like when we are moving towards from VM to containerized environment, so database still exists in the VM island only. So lot of people told like it's a challenge for database to run in a containerized environment because they come up with a lot of issues like it needs high resources, high CPU, high memory. The data has to be persisted. If those things are gone, like entire logic may fail. And there raised a lot of concerns about this kind of issues actually. But there are certain measures to overcome all those issues actually. So I would like to point each measures and I would like to explain each measures how you can overcome it. And so without wasting any time, just get into the video. Use stateful sets. Stateful sets are type of Kubernetes controller that allows you to manage stateful application like database. They ensure that each pod has a unique identity and that state is maintained across pod rescheduling. So stateful set is one of the Kubernetes controller. So there is a lot of difference between running an object in deployment spec on stateful set. So deployment, it will spin up the pod anywhere of the node, and stateful set, it will have a dedicated node. It will spin up over only there only. Ensure data persistency. Container or ephemeral data store is lost when container is terminated. So it is very obvious whenever you run any pod or container, if the container gets killed or pod is deleted, your data inside the container will automatically get or deleted. To ensure data persistency, what you have to do is you have to use persistent volume or persistent volume claim to store the data outside the container and mount the volume to the container. Use proper resource allocation. You have to give the proper resources, basically CPU and memory, how much of CPU is required, how much of memory is required for your pod, and you can define how much it is required on the pod itself, and to ensure that you allocate the right amount of resources to each container and monitor the usage regularly. Use network policy, the Kubernetes network policy, to control the traffic between the containers and the database. This prevents unauthorized access and ensure the security of the data. So this is one of the critical component database. So not all traffic should has to go to the database. So basically, like if pod A has an application, so it should connect only the database, means the connection from the pod A has to get it allowed, so that you can tweak by using a network policy by egressing and all those things. Use config management tool. Use tools like Ansible, Puppet, and Chef to manage the configuration of the database. This ensures the consistency across the container and make it easier to manage. This I don't want to explain more. It's config management tool. You should know it. Use load balancer. Load balancer is to distribute the traffic across the containers. This ensures that the container are not overwhelmed with the traffic and helps to maintain a high availability. So you have to associate it with an external load balancer like AWS, ELB, and all those things. And you have to make sure your database request is completely, what you can say, it's properly like distribute the traffic. It should not get highly overwhelmed. Use backup and disaster recovery. Databases are critical to essential. It is to have a backup and disaster recovery in plan in place. Use tool like Velero or Stash to backup and restore the data. Use container security best practice. Okay, so the container security best practice to ensure that container are secure. This includes limiting the privileges of the container, scanning the images of the vulnerabilities, and using such security policies. Use logging and monitoring. Logging and monitoring tools to monitor the performance and the health of the container and the database itself. This helps to identify the issues before they become critical. Test, test, and test. Test your database container thoroughly before deploying them into the production. This includes testing of performance, scalability, reliability. Use load test tools like JMeter, Gatling to stimulate the real world traffic. So that's all I have, guys. I hope you might have enjoyed it. At these points, you have to consider it when you are migrating your database from VM to container. Thank you so much. We'll see you on another video.